Going to say about Panpsychism. I think we don't need much introduction. Giulio Tononi and Larissa Albantakis is going to exchange, but they will talk about IIT. Please, my questions. Or any remaining questions about IIT?
Thank you now, especially for risking scientific panic, because having organized something in Panpsychism from the point of view of science. We all do, by the way, those who have been here are flagged as potential reprobates. Anyhow, I think we'll play it by ear, Larissa and I, and trying to address, by first introducing a bit IIT, the main ideas behind it, and which way you should address it. Then giving you a sense, and that would be Larissa, of how you actually calculate these things from some very simple system where you can do it rigorously. And then address, interspersed with questions, the combination problem, so that we can sort of go back to what David said yesterday in the church, from a more sort of heathen perspective than he did. And finally addressed more generally the issue of where do we find consciousness in the world. Basically the consciousness here, there, but not everywhere, as we tried to do with Christopher Koch in a recent publication. So I think we all understand the problem here. Today we had a perfect demonstration of this. Is there consciousness in plants? Is there consciousness in bees? Is there consciousness in robots? Is there consciousness in computer simulations? This always comes up, and the criteria that people come up with are, well, if they are intelligent enough, if they're enough like us, or maybe there is emotion, they're complex enough, or they show ability to learn. You can come up with all kinds of things, and it's never, ever conclusive. You just can't answer the question that way. This is not just a problem here in the context of Panpsychism, it's a problem everywhere, because at the ASSC meeting, you see again the same problem when you have to deal with, did you really see it or did you not, depending on the criteria, in a task in which you're just judging the presence of a letter on the screen. It comes up with patients who have a brain island of activity. Is he conscious of just pain and nothing else, or he's not conscious at all? And you can go on forever. And sleepwalking, and octopi, you name it. Everything is such that in the end we put our hands up in the air and say, well, let's forget talking about consciousness, let's just do some good science. Well, I completely disagree with this. One can talk about consciousness, but one needs, as you know, this has been my position for a while, a theory. But one important message that never gets through is that integrated information theory, IIT, from now on, is something that begins with our own consciousness, with experience. Where consciousness, of course, is synonymous with experience. It is not beginning from the brain, matter, complexity, something that I feel intuitively must be conscious because it's such a fancy piece of machinery or so, or because it does such fancy things. No, it comes from the only place where we have the absolute evidence that there is a phenomenon in need of explanation. That's the hard problem. That is, there is my own experience. I wake up, I have experience. And then sometimes that goes away, and at some point it will go away forever. That is the only evidential basis on which you have to base a theory, because it's the only place where we know the phenomenon exists. It's a rather big phenomenon, because if you take that phenomenon out, nothing worth talking about is left. All right, so IIT starts from phenomenology, not from matter, not from the brain, not from behavior, not from the complexity of internal states. In fact, I think one can safely claim, and we heard it even today, if you try to start from the brain, behavior, and so on and so forth, you'll never get to phenomenology. That's the hard problem, and the way that it is so hard, I like to say, that it is not solvable. You can't do that. You have to presuppose consciousness to get it out from anywhere. So the way to go is starting from your own experience when you wake up in the morning and you see your body in the bed with colors and shapes and other things and space and so on. And then you wonder, well, I suppose there is a physical world out there. How could that physical world do it? That's the way to think about that. Consciousness exists, it's there. Well, if there is a physical world, how does it have to be structured? So IIT essentially is trying to find out what are the essential properties of every experience we have. My own experience. I hope yours is similar. My own, I think there are 5 fundamental properties that every experience I ever had always shared, and I cannot think of no experience that wouldn't have them in my own case. These are the axioms, the properties of every experience. And then you translate these axioms into postulate. You say, okay, if this is what consciousness is like, and that's the only place where I know it for sure, how does the physical world have to be arranged in order to account for these properties, these axioms? And those are the postulates, the translation of the axiom into requirements for physical systems. The axioms and postulates are 5: intrinsic existence, composition, information, integration, and exclusion. And now, inevitably, and with apologies for those who heard this at the tutorial, I'll briefly say what they are. We can, of course, discuss them. Keep in mind, this is my own consciousness, I hope also yours. So the first statement is that it exists. Experience exists. My own experience exists when I wake up, and it exists intrinsically, meaning you don't need an external observer to tell you that you are conscious, you just are intrinsically. How do we translate this? Now, we assume that there is a physical world out there. I grant you that much. And for the sake of the argument, we'll say that it is made of mechanisms in a state. Mechanisms could be neurons, states could be firing or not firing, but of course it could also be logic gates, or it could be anything else, atom, quarks, you name it, the kind of physical world we talk about. And so assuming that there is such a physical world made, simply speaking, of mechanisms in state, we translate this phenomenological axiom into something about these mechanisms. So they must exist. And the translation that IIT proposes for existence is they must have cause-effect power. That is, they must be able to make a difference. If something does not make any difference, or nothing makes a difference to it, we might as well cancel it from the catalog of things that exist. So it must exist in the sense of having, we call it cause-effect power. But it has to be intrinsic existence, and this is going to be crucial. My consciousness exists whether or not somebody is observing. Well, this physical mechanism in a state must have cause-effect power upon itself. That is the intrinsic part. It must exist, make a difference to itself, not just to somebody outside who observes. And this is crucial. Now, if you look at this, take 3 neurons, which are really represented by logic gates here. This guy is an OR gate, a mechanism, and it's on now, right now. This is an AND gate off, an XOR gate off, and then there are some other guys. Let's consider this as a possible system, maybe that part of your brain, the NCC, which is responsible for your own consciousness, whatever it is, and we still don't know what it is for sure. 1 on, 2 off, okay? Is this something that exists and exists intrinsically, this candidate system here? Well, all you need to show is that in principle, it can make a difference to itself. And so the way we do that is we consider all possible past states of this system. Since it's 3 binary units, they are 8, from 0, 0, 0 to 1, 1, 1, and all possible future states. We can discuss later on why you need both past and future, so to speak, both cause and effect. And we can show by perturbing, which is indicated here like this is a causal analysis, you must have cause-effect power, you can't just observe it. By perturbing that, for instance, this previous state, 1, 1, 0, could have led to the current state. So you put in 1, 1, 0, this system will give you this state. And if you put it in this state, it will produce a future state. This happens to be a deterministic system. Doesn't really matter. But for the sake of the argument that this is a candidate, it exists, and it makes a difference to itself. That's the translation of the axiom of existence. Now here's one axiom that matters a lot then for today's topic, that is the combination problem. Consciousness is structured, meaning when I have an experience, it typically has, so to speak, parts, but really better structure. There is a left and the right side, there's color and shape. There's combinations of colors and shape, for instance, the color blue, a book, a blue book, and so on. So you have all of these things that make the experience what it is in a very rich manner. This translates directly into a postulate that says, okay, remember our little candidate system, A, B, C here, just take it in isolation right now. And what we demand is that also its parts or subset of elements, these are the elementary units, have cause-effect power. If they don't have cause-effect power, they don't exist. So not only the system, but its parts must have cause-effect power. And here how we can study, for instance, what difference this element being off makes to the system. And it makes a difference. So it has cause-effect power, and then we do it for this guy, for these two, these two, these two, and these three. So all combinations, that is the power set of elements of the system. That's the translation. It's a direct translation. And it seems simple enough, but I think you can go very far with this simple axiom and postulates. Third axiom, information. Every experience is what it is. It's the particular way it is. This is one of those axioms that are so obvious that people never really pay attention to it, and actually I would say never understand what it means. So when I have the experience I'm having now, but just as much when I have an experience of pure darkness, what makes that experience what it is a lot of stuff. The simplest way to think about that is that what makes it what it is also what makes it different from trillions of other experiences, things of every frame of every possible movie. So there must be something that makes this experience this one and not any other experience. And that's a lot of information said in the proper way, which is very different from shallow information. How do we do this in terms of postulate? So you can see that the cause-effect structure specified by the system must be differentiated with the specific way it is, and therefore different from other cause-effect structures. Now, what is a cause-effect structure? Here is indicated, and Larissa will just take you through a bit more in detail about how we do this. So again, we have our system ABC in a state. Now, crucially, we are not just satisfied with asking, well, can the system make a difference to itself? We already answered yes, and its parts, yes. We ask what kind of a difference does it make? And to do that, we must try out all possible past states and all possible future states and ask, well, element A on in this system, how does it really specify the past states of the system itself? Turns out, for instance, that these 6 states out of 8 are compatible with this being an OR gate on in this system. And these 2 states, 0, 0, 0 and 1, 0, 0, are not. So the fact that this is an OR gate on now specifies this probability distribution about the past. And also, if you work it out, that probability distribution about the future. That's what difference it makes for this guy to be on in this system, given it is an OR gate. Then you do this for B, and for C, and for A, B, A, C, B, C, A, B, C, for the entire composition of the system. And this is what difference they all make to the system itself. Yes?
Sorry to interrupt. Just wondering, so that's the cause and effect repertoire in the next time steps, or is it the whole history repertoire?
No, this is, if we assume now, for the sake of the argument, that there is a particular time step.
Yeah, sure.
Okay?
Yeah.
So we are now in the present, the current state, which is this, and the current state informs the past and the future state of the system in that particular way, in this combination manner. So we don't just look at what the system as a whole does to itself, but also its parts. In fact, a good way to see why this really is information, a very different way from the way normally people think about that sort of information theory, is this. Now we put those 8 past states and 8 future states as axes in a space we call cause-effect space. So these are all possible past states and future states of the system, so to speak. And then every one of those cause-effect repertoires, these things here, are points in that space, where each axis has a certain probability. And so this null point here is the possible past and future states if the system had no mechanisms whatsoever. So it doesn't in any way inform the past and the future. If I have no mechanisms, say nothing. Everything is equally possible in the past and in the future. But because I have mechanisms, I actually inform that cause-effect space, and this is precisely how I inform it. I create that constellation, if you wish. That's the cause-effect structure. This is nothing else but this, represented in cause-effect space as a constellation. This is what A says, this is what B says, C says, A, B, and so on and so forth. That's sort of how we are going to describe some things in a moment. Fourth action, integration. So I told you to exist, you must make a difference to yourself. Now, one thing about phenomenology is that each experience is unified. You cannot cut it into pieces. You cannot consider the left and the right side of the visual field in isolation. You can talk about them, but when you experience them, it's always one. This is a very important point that has been made in philosophy. Each experience is unified, it is irreducible to components. But the components are there, it's just that the whole is irreducible. Now, in terms of existence, this means that the cause-effect structure that the system specifies, that we just saw before, must also be irreducible. Meaning, it must be the case that the whole, when it specifies this cause-effect structure, is doing something above and beyond what its parts do. The whole is, in terms of cause-effect power, more than the sum of its parts. This means that if you had a whole that doesn't do anything more than the parts, you might again throw it out of the basket of things that exist in the world because it doesn't do anything. Only the parts exist. This is how we actually test it. We take the system, we cut it in all possible ways. This is called the minimum information partition, the kindest cut of all, the one that makes the least of a difference. After we cut the system physically, and we see what kind of cause-effect structure does it specify cut, we get, in this case, that it specifies this cause-effect structure. This is clearly much less than what it was doing as an entire system. And we can then measure the difference between the cause-effect structure that the system specifies when it is a whole system and the one that it specifies when it's cut. That difference is the extent to which it is integrated. It is a whole above and beyond the parts. This quantity is the quantity that big phi there measures, as we'll hear again from Larissa. And finally, the last axiom, which is that every experience, it's again a property of your experience, is singular in content and spatial-temporal grain. That means that there is never a superposition of multiple experiences. This is illustrated here by saying, this is the experience you're having when you wake up in the morning, say. That is the experience you're having, and it's only one. There is not simultaneously another experience being had, like the same experience but without the color. There's not another you at the same time who's having the same experience minus the color, or minus the faces, or minus the left half of the visual field, like all these neuropsychological syndromes, okay? There is the experience you're having, period. There is also no larger experience than that, like the one that incorporates the noise of the alarm bell before you actually hear it, while we know that your auditory cortex is already firing. So it is what it is, not less and not more. There's only one. This is true over elements, but it's also true over space and time. It flows at a particular time interval, let's say hundreds of milliseconds, it seems like. There's not simultaneously a bunch of much faster experiences flowing through, or much slower experiences, each of them lasting, say, a minute, an hour, or something like that. You had a question there?
An example where you might have color, form, and motion misbinding or unbound. Whatever you just experience would be the singular, unified experience.
Yeah, you're having an
So be
experience.
integrated, and think about that as misbinding or being torn apart.
Yeah, that is not the experience that is torn apart. The experience is always one. You may have a misbind. You will actually have a slide about something like that, meaning you attribute a color to the wrong object. Okay, that would be a case. So the object in the physical world is a red triangle, but you may bind the color with another object. But the experience is one. Okay, it's not correct with respect to the object, but it's always integrated. Now,
Question.
yeah.
What's the argument against there being another consciousness that's operating at 1/10 the speed? Why can't
There's no argument. It's just my consciousness is like that. There's only one.
So there might be another one there.
There might be all kind of other stuff in the world. We are dealing with consciousness, and the only consciousness I know about, strictly speaking, is mine. I assume yours is similar for the other
in your
reasons.
brain.
Yeah, there might be. But I'm saying mine is always one. It's not a superposition.
Sorry, one last.
Yeah.
I still struggle to really understand quite the difference from the point of view of chronology between exclusion and integration. They seem to potentially mutually imply each other.
No.
To me.
Integration means that an experience cannot be subdivided into independent components. So it's one. And exclusion says it is only one. There is only one experience. Okay? And here is, then you can actually calculate these things. Here's what we actually do. So remember that system now, ABC, where we come back with D and E as the additional elements that were there. We can consider ABC in isolation, but we can consider the whole thing. Now, what we did was calculate the conceptual structure that's specified by ABC in the state, treating these as background conditions. But of course, nothing in the world says that it should have been ABC that we should calculate. It could have been just BC, AC, AB, or a bigger thing like ABCD, ABCDE, etc. All of that, in principle, can be examined. And we do that. So we calculate the cause-effect structure generated by ABC, which is this. Then we do the one, for instance, that is specified by this, like B and C. And that's that. And then we do the same for a bigger one, A, B, C, D. And that's that. And we could go on for all the possible subsets at this particular time scale. Then we could do this at different time scales, etc., etc. The end result is that you get these three, for instance, or many more. This is irreducible to the tune of 0.44, this to the tune of 1, this 1.92. And again, for our criterion for existence is you make a difference to yourself, and only if you make a difference to yourself do you exist. Exclusion imposes the condition that it's only the one that makes the most difference to yourself that exists, because otherwise there would be a superposition of causes over the same elements. Yes?
So if D made a difference, but over a long time delay through the environment back to itself,
Yeah.
would you then include D, or is
No,
D not?
no way.
So through the
You
environment...
always, you just have to do this. In principle, you have to do this over all elements, over all spatial grains, over all temporal intervals. If you can include the entire world, you can do that, okay? Because it's all sort of connected at the end. But IIT says that the only thing that does it is the one that is a maximum over element, space, and time, very precisely, as you would see. What you end up with, isolating these three guys again, in this state, is in this state, this system on, off, off, with this mechanism specifies a cause-effect structure, which we have now checked is irreducible. In fact, it is maximally irreducible, so it satisfies integration and exclusion. And we plot it like this, where this particular cause-effect repertoire, which is maximally reducible, is called a concept, and the entire cause-effect structure, which is now made of concepts, is called a conceptual structure. It's represented this way or that way. These are the various concepts. Each of them exists, again, in a, to an amount that is calculated by integrated information called small phi for the concepts, and the entire thing, the entire constellation, exists to an extent that is captured by the overall integrated information, which is called big phi, again, integrated information, and that is how much conscious it is. In fact, in IIT, an experience is identical with a conceptual structure, which we can now in principle measure for anything in principle. The quantity of experience, how much consciousness there is there, is given by a big phi, how irreducible the conceptual structure is, and the quality of experience, the form in cause-effect space of the conceptual structure, is telling you exactly what it feels like to be that thing. So that little system we had before in that state was like something by 1.92. So there was something it was like to be that. And what it was like is exactly this. This is what IIT says. Okay? Now this is, remember, based on your own phenomenology, trying to identify what are the essential properties and the only essential properties of every experience you have, translate this conceptually and then to mathematical terms, and apply this to physical systems. Of course, these are simulated physical systems, just to, you can do that. And now Larissa will try to give you a better sense of how we actually bottom up, take a system, and get those numbers out.
Yeah, of course you can find.
But before that, maybe is there any questions to Giulio at this point?
You want, depending what it is, if it's useful to go through this a little bit more in detail, so that
Can we wait
it is,
then?
if the question more general is
I'd like
now.
to just follow on from the time question. So you suggested that you do it over all the elements of the system, which is fine, and over all spatial grains and all temporal grains. How do you know which temporal grains to do it over? Do you just define a range? Because there might be, for instance, a very critical but very weak interaction that only becomes cyclical after 1,000 steps,
Yes.
and presumably that's very hard to calculate.
Yes.
So is it just a matter of pragmatics, or is there some way
Well,
to be sure
it
about
is
that?
a matter of pragmatics in the sense that we practically cannot calculate this for anything more than these simple systems
Yeah.
in a rigorous manner. In a realistic system like brains, okay, then we can make some heuristic decisions. And for instance, the spatial grain is going to be probably either neurons or mini columns or something
Sure.
like that.
Yeah.
And the temporal grain is going to be either a few milliseconds or a few tens or hundreds of milliseconds, but anything longer is unlikely. Okay?
Sure.
So you can use tricks.
Mm.
But fundamentally, if you have a completely alien system where you have no idea about the causal interaction, you should sort of
Yeah, do it overall. Yeah, fair enough. Thanks.
Is it all right?
Sorry, but I'm totally new to this, so maybe it's a stupid question, or not conscious enough. But this phi, or this phi, is that equal to experience? Is that number qualifies experience? Is that what it means?
no.
What does it really mean?
It tells you how much consciousness
Okay.
is, the quantity, not the quality. One number could never express what I'm experiencing now, obviously. It just tells me, am I very conscious, little conscious, or not at all, okay? And instead, the quality is this. So IIT gives you both the quantity and the quality, and there's no way of doing the two things separately in my mind. Yeah.
I have two questions. This one definitely is for now. So you start from consciousness, but it seems to me that what you're taking from your experience is something that you can then just translate into how you're going to build up the physical system. And so I'm concerned that there doesn't seem to be any necessary role for consciousness in that resulting system, like no coherent place for it, in the sense that consciousness needs the physical system to exist, because it's dependent on the structure of the physical system. The physical system doesn't need consciousness for anything. So I'm not really sure how starting from experience really builds consciousness into it. It seems like in the end it's still starting from physical.
It seems to me you're still having the usual problem. Starting from experience means that you take experience for real. That's the only thing we're sure about. Everything else is conjecture. And of course it's a good conjecture. So we postulate there is a physical world and we're still struggling to figure out what it is made of. Quantum fields of different kinds, or is it particles, and so on and so forth. Those are very good things. We believe there are people out there, we believe there are particles, maybe there are fields. Those are all postulates. But your consciousness, as was recognized long ago, is not a postulate. You just have it. So it is necessary to start from experience. You have to try to avoid thinking that you first start from experience, whatever that means, then you say something about the physical world, and then somehow you have to get experience out of the physical world again. You'll never get experience out of the physical world if you didn't have it there in the first place. Let's go on a little bit, because I want to get to issues like the combination problem and so on, that then we can talk about this more maybe with a beer.
Yeah, but in principle it just means you can't go this way, and once you're here, you cross this out again. That just doesn't make any sense. I guess that's what he would say.
Yeah.
But, okay. So, if you want to calculate integrated information in the system, first you have to define your system. Here we have one that is a system of mechanisms in a state, and we have an OR gate, an AND gate, an XOR gate, and some other elements that input and output to this. But the system we want to look at as our candidate set will be ABC. So the other elements are background conditions. We just take them to be in the state that they're currently in, and they're not, like, they can just take them to be what they are. And then out of these mechanisms, we can get the transition probability matrix, or TPM, which just tells you that for every possible state of the system, which is the next state of the system. So you have to perturb the system into all possible states, and then you measure what's the next one. In this case, we have a deterministic system. That's why there's only zeros and ones, but in principle, it could be probabilistic. You just have to do it more often, right? Perturbations. Also, it shows you that this is a perturbational way to assess the system. So it's not just enough to take all the observed state. You really have to get all the states of the system. And then we're calculating this for 3 logic gates now, and I know many of you are wondering how you would calculate it for a real system. So the starting point is that you need this transition probability matrix. For a real system, you have to decide which grain size you use, what your elements are, but then for the explicit calculation, you would need to have this transition probability matrix. So now,
doesn't really show up, but we are in state 1, 0, 0 right now, which is this state. So if the information that we have from all those elements that we are in 1, 0, 0, the next state will be 0, 0, 1. And if we go the other way around, we are now in 1, 0, 0, so the past states could either have been 1, 1, 0 or 0, 0, 1. Giulio told you about the axioms and postulates. So the postulates of information integration with exclusion have to apply for the system of mechanisms as a whole, but also for the individual mechanisms of the system. A mechanism does not exist for the system if it doesn't comply with those three postulates. So that means that only a mechanism that specifies differences that make a difference within the system counts, which is measured by the cause-effect information of the mechanism. A mechanism must also be irreducible to its parts, which is measured by the integrated information small phi. And then only the maximum of integrated information counts, which means that over all the possible inputs and outputs of a mechanism, the actual function of that mechanism for the system is its concept, its maximum of integrated information. And I show you what this means based on our example system. So we have ABC, and as a mechanism we now pick A. A is an OR gate, it is in the state on, and from that we can infer with Bayes' rule that because A is now on, ABC must have been in any of these states, and it couldn't possibly have been in a state where both B and C were off, because then A would be off now, right? That's so that is our cause repertoire, the possible past states of the system given that A is now on. And in order to get the cause information of A, we compare that to the unconstrained repertoire, where we don't know the state of A. So in this case, all possible states were had the same probability to be a past state of the system. And if you take the distance between these two distributions, which we now use the Earth, a metric that is called Earth mover's distance. You can ask me how that works later, but it just measures how you would transform this distribution into this distribution. We get a value of 0.32. Then the same that is true for the past is also true for the future. So A in the state on says something about the future of the system. So A has an output to B and C, and in this case, B is an AND gate, so A being on doesn't really say what it will be actually, but it says that it's more probable that B will be on in the next time step, which is somewhere in this distribution. So you also compare that to all states being equally likely and calculate the distance between these distributions, which gives you another value. So the overall cause-effect information, the information that A being on specifies about the system, is the minimum of those two. And I'm not sure if we have, yes, we have a slide for that. This is because, so you take the minimum because in order to, a mechanism only generates information, intrinsic information for the system if it has both selective causes and selective effects. So if a mechanism would only get inputs from the system but has no output to the system, then its effect information would be 0. And if a mechanism would only get would only output to the system but doesn't receive input from the system, then its cause information about the system would be 0. And in both cases, the mechanism is not a difference that makes a difference to the system, so we don't count it. Yes?
Sorry, can I ask you to go back one slide? I've missed something. And go back through what the cause effect information is.
So the cause, did you understand?
Oh, so the CI and the
ones?
EI.
So
So CI is,
the cause information is, given that I know the state of A is on,
yeah,
what could the probability distribution of past states of the system. In this case, it's this probability distribution, and you see that all states are possible except 0, 0, 0 and 1, 0, 0, where both B and C are off.
In words, it is how much of a difference does A being on make to my past states in the system, and the effect information, how much of a difference do I make to future states in the system.
Okay, so is it a count of the number of states that are excluded because A was on,
Well,
in a sense?
In a sense, it's just not the
But
number, it's the
probabilistic, it's not
probability.
just a count, but
So it's probabilistic, and it's EMD is the distance between these two distributions?
Yes.
So it's got to be a statistical measure?
it's the Wasserstein measure.
It's like, I mean, previously, another distance measure is just the Kullback-Leibler metric, which people are used to, but we have moved away from using that because it's not a true metric, it's not symmetrical, and it can be unbounded. That is why we looked for a better way to measure the distances, and the Earth moves distance is what it is for now.
Okay, so just go through EI. That CI is the difference that A being 1 makes to the past, and EI is the difference that A makes to the future?
Yes, of the system.
Using the same Earth moves distance?
Exactly.
Okay.
And then the overall cause-effect information is the minimum because you need both causes and effects. So if I would have only a minimal effect, the cause-effect information would also be small. Okay. And then also mechanisms, and we talked about the composition, that in principle A and B together could be a mechanism, but that is only true if A and B together make an irreducible difference to the system. So in this case, this is not true. So A and B together here have completely different inputs and outputs. So if we would partition between the two, we do not lose any information about the past of the system or the future of the system here. So in this case, A and B are not integrated. If, on the other hand, we look at ABC, all three elements as being a potential mechanism, in this case, ABC specifies this cause repertoire. So there are only two possible past states given the current state of A, B, and C. And if we now try to noise any of those connections, causally partition between the elements, we always lose information no matter what we cut and how we cut. And we find the partition that makes the minimal difference, so the weakest link, and that is what we cut. In this case, we would partition ABC into what AB says about C and what C says about AB, and this is the so the cause repertoire of AB over C times the cause repertoire of C over AB gives this distribution, and then again calculate the distance between the two, which is then the integrated information of the cause side. Okay, and we do the same for the effect repertoire. So in this case, ABC, since this is a deterministic system, perfectly determines the future state, but then we partition these links, and the weakest cut is here cutting off B from ABC, and we lose a bit of information, 0.25 with the Earth moving distance. So the irreducibility, the integrated information of the mechanism, is how much of the cause-effect information do we lose if we cut the weakest link of the mechanism. And again, the system must be integrated on both, the mechanism must be integrated both on the cause and effect side. So this is an example for an integrated mechanism. We have a parity logic gate and the majority logic gate. So this is actually non-parity, meaning it's on if its inputs are pair. And majority is on when its the majority of its inputs are on. So in this case, the inputs and outputs are totally distinct, so not integrated. in this case, both the input side and the output side are integrated, and for the cause side, you could view it this way. A says that its inputs must have been paired. B says that the majority of its inputs were on. And together, they actually uniquely specify that all the 4 inputs must have been on. Now, you could say that, okay, I know this from A and B, but here it's important to take the intrinsic perspective of the mechanism. So the only way that the system can know that all 4 inputs were on is with the information of A and B together. So that's the integrated information here. And the same is true for the future, so only A and B together actually influence this end bit. And if the output side, if they had different outputs, then the effect repertoire would not be integrated. And if they had different inputs, the cause repertoire would not be integrated. And in both cases, the mechanism as a whole would not be integrated. So only this is a higher order mechanism, as we call it, of A and B, because A, B together specify both integrated cause information and integrated effect information. Now comes the exclusion. This is a bit tricky. So for now, we've skip it. Okay.
Anybody can ask questions of check operators, otherwise I'm afraid we can get to the combination problem.
But if we apply the exclusion, we find a concept. So this is the maximally irreducible cause and effect repertoire of a mechanism. An exclusion just says it doesn't have to be all of them, but you choose the ones where A in its state says the most about, basically. So the concept can be viewed as the core function of the mechanism for the system itself. Now, again, information integration and exclusion have to apply for the system as a whole then. So for all the combinations of mechanisms in the system, we find the concept. And this gives you the conceptual structure of the system ABC. Now, in order for the system to exist from its own intrinsic perspective, this conceptual structure must be integrated and exclusive. Meaning that if you partition the system, you need to lose information. In this case, you could view this as one system from the outside, right? But from the inside, it can never be one system because you can cut between this and you don't lose any information. So from the intrinsic perspective, this cannot be a unified system. The same is true if there's only unilateral connections between the two parts. So this cannot be a unified system from the intrinsic perspective because only this side knows about the other side because it gets causes, but it doesn't have effects back. So it cannot be a unified system from the intrinsic perspective. And the same here. So this is the rationale for why if we partition the system, we partition it unidirectionally. So we cut either the causes or the effects and see how much information we lose. We again find the minimum partition, which here is that we cut the effects of A and B on C. This is the minimum partition in the system. And if we do this, if we noise this connection, make them causally ineffective, we lose 4 of these concepts. So the only thing we are left with is what A says about B and B says about A. So the concepts A and B are still intact, but all the other concepts are lost. And you can see this here in cause-effect space. All stars have disappeared except for the ones for A and B. So big phi, the integrated information of the whole system, is then evaluated as the distance between this structure and this structure, or the distance between this constellation, all these cause-effect, of course, and these ones. Again, we use an extended version of the Earth mover's distance, which basically just measures the distance between all these probability distributions to the set of this probability distributions. How this is exactly done, you can ask me later. Okay. And then we already here at the exclusion postulate over the system that, so we have included D and E and F here again. What we have looked at was our candidate system ABC, and we found that it had a big phi integrated information of 1.92. But now we have to check all the other possible sets. And only the one over the same elements, there can only be one entity, one causal entity. That's the idea behind it. So we need to check all the sets of elements and evaluate them in the same way as we evaluated A, B, and C. And then we find here that A, B, and C have the maximum of integrated information. So they form a complex. And just briefly, so all the smaller ones may have some integrated information, but then they don't really exist out of themselves because they actually participate in A, B, and C. And all the larger structures have no integrated information in this case because they're just unidirectionally connected to the rest of the system. If there are unidirectional connections, we know automatically that it cannot be an integrated complex. So that makes calculating it a bit easier. Once we have found the complex in the system, the conceptual structure of that system is its experience. That's the identity again, the quality of this experience. And then,
so,
can I be somewhat selfish because I have to leave soon and I have a question I would love to ask before I go. I think it fits here, but maybe it can be integrated in the rest of the talk. So in terms of the sort of the mathematics, I mean, I'm no mathematician, but I'm happy to believe it's all consistent and sounds true. Where the thing I've sort of been battling a lot with is the issue of scales and levels of things. And for example, like Shell asked the question yesterday, I think about in terms of anaesthesia, you know, you have this sort of all or none experience. And I know the idea is that, you know, you're talking about systems with very small numbers of states, but obviously as it grows, you have infinite, you know, like really huge expanses in the value of phi. But at the same time, you claim that even if you had, say, for example, like in an exercised brain, you clearly still have a system that's buzzing. You know, it's doing something. It has a degree of complexity of phi, and we'll say that's 1,000 nodes versus 1 trillion in a wave brain or something like that. And so I'm presuming the response would be, well, at 1,000 nodes, it's so small that it's sort of nothing. Okay? And so then the question is then, in terms of measuring this, so in terms of a completely theoretical idea, that's fine, but in terms of then translating into a testable sphere, I just don't know how we can ever look at, well, what scale are we looking at? If the 1,000 nodes that we see in anesthesia's not enough, then we've got 300 electrodes or whatever it is in an MEG that, you know, high density MEG. I feel like we then would follow that, well, that's not enough of a scale.
yeah.
You know, so if we've got some people using intracranial electrodes and are finding measures of phi
Yeah.
on a very local circuit, other people are using, you know, I think Emil showed a slide with, well, that was not phi, but like you had 18 electrodes or something, and in the fly I think there's 10 electrodes or this sort of stuff. So is there some way to say, well, we should actually, if we're finding it at this small level with 1,000 nodes, it probably is not what we're supposed to be looking for.
Yeah, there are many things embedded into this, but let me just say a few things because they are useful to clarify things. So phi is an absolute measure. It would, okay, the true phi. So in these systems, it's the number you get. In the real system that we can probe, let's say Marcello, because today we're not going to talk about empirical tests of this theory. But that was, of course, an empirical test we tried. But we had to deal with 260 electrodes in an EEG, with the TMS pulse, etc. So all we can measure there is a differential. We go from wake to sleep, to anesthesia, etc., and we see that it jumps down and it classifies patients very well in many different conditions at the individual level. The intriguing thing, by the way, in those data that Marcello showed is that the only place where it was graded, so to speak, was minimally conscious patient, who really are sort of in between, and a little bit stage 1 in sleep. And so, you know, and propofol, it varies. In any case, the point is those are differential measures that you can apply to a human, to a rat, to a machine, to anything with whatever tools you have available, hoping that you can see this differential as predicted by the theory. But by no means is that the right number, okay? So the phi value, in fact, we don't call it phi. In one case, it's called perturbational complexity index, etc., because we need the absolute numbers for the absolute entities. So far, we're going to deal with differential evaluations. And then there will be the problem, but maybe we'll talk about that later, of even if we had the absolute numbers, okay? If you get a number like 1,000 in the anesthetized human brain, that's where the absolute number on the proper elements, etc. Is that little, a lot, or what? You wake up the patient tells you, it wasn't like much to, you know, I don't know, I wasn't there, okay? Then we know that that is a very low number. According to the theory, there is something that's like to be that, but it's really minimal, okay? And so we basically don't care, because you don't care. But let's not go to the ethical implication. Let me do this now to just briefly summarize. Then again, we start from phenomenology. The axioms say consciousness exists intrinsically. It is structured, meaning it has a lot of parts and so on. It is the way it is. It is irreducible, and it is only one. That's the key properties of every experience. And then it translates this into postulate that you could in principle apply that say, well, to satisfy these properties, physical systems, assuming they exist, which we believe they do, they must have cause-effect power on themselves, so intrinsically. They must be structured in terms of cause-effect powers. The parts may have cause-effect power. They must be the particular way it is. The cause-effect power must say certain things. It must be irreducible cause-effect power, and there's only one cause-effect power structure or conceptual structure over a set of elements in spatial grain. That's what you heard so far. Now, at this meeting, we want to do two specific things after introducing this, albeit briefly. Which is one is deal with the combination problem. Because, of course, that is one of the things IIT does or purports to do. And we heard yesterday from David that that's a big problem, certainly for panpsychism. In any case, it's a problem that needs to be addressed. So let me say a few things about how IIT addresses the combination problem. Not because IIT is panpsychist, but because it's a fundamental problem in consciousness itself. One statement that follows from IIT is that an elementary mechanism, like say this OR gate on here, can contribute to experience only if it is part of a complex, that is a local maximum of big phi, as we saw before. So here you see this example. We have again our system ABC. The analysis that Larissa showed you shows that this is a complex. It's a maximum of integrated information with phi. So this thing exists, it's conscious, 192 in a particular way which we won't show. Okay? Another thing we notice is that this system, a bigger system which includes D, since it's not a maximum anymore, I showed you before with exclusion, this system does not exist, is not conscious. Only this exists, not this larger. But intriguingly here, I want to compare this guy with this guy. Okay, this is another kind of gate. It's a copy gate that copies the state of this into the state of that, essentially. It does something. If you look at it from the extrinsic perspective, it has a cause-effect repertoire. But it doesn't do within a complex. A has a cause-effect repertoire within this complex, so it does something to experience. This doesn't do a damn thing. You can study it from the outside, but it doesn't exist for anything. This is a key thing when it comes to panpsychism. And it's a very key thing, David, to open your eyes for. Here is a different situation, which is an element can contribute to experience only if it has the spatial grain associated with maximum of big phi. This is true also for temporal grain and state. This is a good case to look at because IIT didn't tell you anything about which particular spatial scale you should look at systematics. Take the brain. Should it be neurons, mini columns, areas, atoms, quarks, you name it. It could be anything, and you could measure, in principle, phi on any of those. But obviously, there is only one experience. There is no superposition, that's the exclusion postulate. Okay. So which one? It can't be arbitrary because consciousness is not arbitrary. It is the one you're having now. It exists, and it exists the way it does. So there must be a principal way to do that. IIT says it is the spatial grain, for instance, at which phi reaches a maximum. Here is an example that was built together with Eric Hoyer and Larissa of a neural system, which is a bit more complicated than usual, with 9 units. And we can look at these units either at the individual level, in which you can have 9 mechanisms like before, some on, some off, or we could macro them, that is, group them into macro elements. For instance, we have group alpha, beta, and gamma. There are many other groupings that you could do. In principle, any one of them. We measure phi at the micro level, meaning A, B, C, D, etc., where you have 9. And we measure phi at the macro level, in this case, these 3 groups of 3. We can do this over small or long intervals of time. Doesn't matter. Whichever way you do it, you get a value. And in this case, we get that the value happens to be higher for the macro level of organization. So if this system defines itself as being made of 3 elements, alpha, beta, and gamma, in 3 macro states, largely on, largely off, or something like that, it has higher integrated information than if you try to define itself at the micro level. This is sort of counterintuitive because generally speaking you think there are so many more details and degrees of freedom and so on at the micro level that, you know, the system seems to really, according to many, exist at the micro level. That's where all the action happens. If you measure it, that is not necessarily true. And maybe, since this is important, Larissa, you can give a brief indication of this in a simpler system like that.
So could I just ask a quick clarification? You've defined it as the maximum.
Yeah.
Can you give an intuition why high value, you know, why the maximum?
Because it's what exists the most. If a cause-effect power is a criterion for existence, you must have cause-effect power to exist. You must have cause-effect power as a whole to exist above the parts. And if there is a competition between existing entities over the same elements, the only one that exists is the one that exists the most, even that experience is singular. Let's do this now briefly in the simple example, because this shows you this definitely counterintuitive thing, that a macro element in space now can have more cause-effect power than a micro.
So this simple system ABCD is all the same elements which are sort of noisy endpoints, meaning that if their 2 inputs are both, if just one of them or both are off, they have a 70% chance of switching on and 30% of staying off. But if both inputs are on, they will for sure be off. So it's like a noisy endpoint. In this case, we have this transition probability matrix. In this case, it's not deterministic because the elements are probabilistic, so there's not just zeros and ones, but actually a lot of gray. And we can measure the effective information, so the cause-effect information, the average cause-effect information sort of this system, this TPM, and it results in being 1.15. Here still indexed, because this is not yet done with the Earth Mover systems, but with Cobalt Black. If we group the same system, if we group AD together into this macro element alpha, and we group CD into beta, then both alpha and beta are mechanisms that are off if their input is off with 81%, and for sure on if their input is on. So this is the macro mechanisms. It's basically these 3 are averaged into the off state. So I think I have the next slide where you can see this better. Yes. So AB together, the elements are coarse-grained into macro elements, and the micro states are also coarse-grained into macro states. So 0, 0, 0, 1, 1, 0 are all macro state off, and state 1, 1 is macro state on of this system. Same for CD. So, right. So this grouping has to be consistent with the element mapping. So you can't just group state 0, 1 with state 1, 1, because that would not correspond to a physical grouping. So we actually are only allowed to group the elements as physical elements and not their state as abstract states. That is an important point. And then we also assume here then that no micro level information is available at the macro level. So if you view the system as alpha and beta, you cannot distinguish between state 0, 1 and 1, 0, because in order to distinguish these two states, you would have to know which one is A and B. But that information is lost if you look at the system at the more macro level. If you do this grouping then, you get this transition probability matrix, and you can already visually see that this one is much more deterministic looking than this one. And if you calculate the average effective information, so the average cause-effect information of this system, the resulting value turns out to be higher than for the microsystem. And we define this as a case of causal emergence, where we call a causal emergence the difference between the effective information at the macro level and the micro level, which in this case is positive.
Yeah, and so again, a lot could be said about this, but just one message is that from the outside we can take a system and describe it at any level we want, in spatial grain, temporal grain, etc. From the inside, from the intrinsic perspective, again in this view of cause-effect power, there is going to be a particular grain size in space and or time at which the system makes most of a difference to itself. And the claim here is that a system exists from its own intrinsic perspective at the spatial temporal grain at which it makes most of a difference to itself. It turns out, if you start measuring this, that it is not, as one would intuitively think based on the notion of supervenience, that is, once you fix the micro level, the macro level is also fixed. There is no mystery or extra ingredient there. That the micro level has more causal power. No, if you actually measure cause-effect power in the proper way, depending on how the system is done, you may have that the system exists more, and according to exclusion, only exists for itself at a macro level. And so it becomes important for every system, the brain or anything, to find out what are the elements and the spatial grain and the temporal grain that make most of the difference to the system. Yes?
It reminds me of quantum formalisms where if you take the aggregate state of a system, then the microstates become indeterminate, and so that's how you can get this sort of aggregation. I don't know, do you have any thoughts on whether...
Yeah, there is a similarity, but one key thing here is that the reason in the end why the macro level can beat the micro level, we say the macro can beat the micro, is because, again, you take the intrinsic perspective, not the observer's perspective. From the intrinsic perspective, if you are the macro system, then you are alpha, beta, and you have the states on and off. And so the difference you make yourself are evaluated based on the, for instance, uniform distribution, the unconstrained distribution of the macro states. The unconstrained distribution of the macro states is, generally speaking, not the same as the unconstrained distribution of the microstates. And that is why the macro can make a difference to itself. Okay, so this is key, and again, it depends on taking the intrinsic perspective, not the extrinsic perspective. So I'll leave this there. If there is an objection to that, I want to make another case about combination. Another statement that follows, let me do this just briefly, from IIT about the combination problem is, now, combinations of elements can contribute experience only if their cause-effect repertoire over the complex is irreducible. This is small phi is 0. So remember our example of 3 elements. Now let's assume we have more grain in the brain. For instance, you are viewing this display, forget the brain, a red square and a blue triangle. Let's say that's what you're seeing on a blank screen. There are all kinds of things going on. Most neurons, though, will be inactive, except for in V4, say, some neurons that are selected for red are on, and some neurons that are selected for blue are on. And in the lateral occipital cortex, object area, so to speak, some neurons that like squares will be on, and some neurons that like triangle will be on. That's roughly what we can expect to happen in a situation like this. Now, you have potential binding problem here. Okay, you need to bind the right shape with the right color. If you put this sort of in the framework we have developed here, very simplified, you will find that the individual neurons, if this were a complex, which we hope it is, would specify the elementary concept. For instance, the neuron that says there is something red, this neuron that is on, is specifying a concept here over the set of neurons that form the MCC, the main concept. It says something about the Fourier distribution in the past and the future. The neuron that says blue, there is something blue, specifies another concept, which is yet another pointer. These are elementary concepts specified by a single neuron, so to speak. Then the neuron that says triangle also does, so to speak, triangle, and the neuron that says square is yet another one. Then there are higher order concepts, that is potentially two neurons together, for instance, the red and the square neurons together also specify a concept which is indicated here. And the way we check this is we actually ask, do red and square together, those two neurons, specify an irreducible cause-effect repertoire on the complex? In this case, they do. It has a small phi value which is not 0, so it actually exists for the system. This binding of red and square exists because the two neurons together make a difference to the system above and beyond what they do separately. That's what binding means, literally, in IIT. On the other hand, you're not seeing, in this easy case, a red triangle or a blue square. That's not there, although the neurons are on. And this translates directly into these two missing concepts, so to speak. If we actually, in this system, go and ask what do the red neuron and the triangle neuron do, they're both on together over the complex, they do nothing that is irreducible. They say something, but then you cut and it makes no difference. So that concept doesn't exist. That's why, so to speak, you don't see a red triangle. So you only see, the only phenomenological distinctions, you see a red square and a blue triangle, says IIT, are supported by irreducible cause-effect repertoires, that is, concepts. And if the cause-effect repertoire is reducible, you don't see it. It doesn't exist, even if the neurons are on. Okay? That's how we can deal with binding in general.
Just to clarify, so
Yeah.
that one doesn't say that system doesn't have, never get the concept of the red triangle. It's just this particular, in this particular state, it is just tend to be 0, right?
It's not a historical thing. So, since we are dealing with binding, binding can be due to a neuron hardwired, say an elementary concept, let's say red triangle. If I see a lot of those, I will develop a neuron that does that. We know this from neuroscience. But here we're talking about a kind of dynamic binding. That is, you don't have to assume that you have neurons for every possible combination. You have the elementary concept, but now I see a red square. Okay? So the idea here that if you are going to see a red square, you're binding them is part of your experience, if and only if the red neuron and the square neuron within the system, within the complex, can make a difference above and beyond what they do separately. Then you see them as a red square. You have the phenomenological impression of a red square. Not just red, not just square, but a red square. On the other hand, even if the two neurons are on, red triangle is not bound. You don't see a red triangle, because the two neurons together don't make any difference on the system above and beyond what they do separately. That's the direct implication.
To what extent is this committed to some kind of local coding where redness and squareness have to be coded by separate units?
I'll get to that in just a moment. So this was just to indicate again from the previous presentation that they can only specify a concept if they do something above and beyond the individual elements. And finally, I remind you this, we saw this again, another thing IIT says about the combination problem is that one element, let's say element A, can only contribute to one experience, one conceptual structure. It cannot also contribute to a partial experience or a larger experience or anything like that. It only does one. So these are all statements that IIT makes about the combination problem. And finally, it ends with this identity, okay, which I won't elaborate. Now let me address your question, and I think more generally something that's useful to look at, with an example that may be a bit difficult, but I think it illustrates many things. It's IIT in the combination problem looking at seeing blue, as opposed to red, by addition and by subtraction. Okay? And this should illuminate several aspects of the theory. And I want to refer here to what sort of happens in neurobiology, although never ideally. This is a normal human brain in a situation in which you may be seeing, for instance, something blue. It could be just the blue field, or it could be the blue triangle. It doesn't matter. Let's say the blue triangle in this particular case, or a blue dot like here. Okay? So you're seeing this. You have a particular experience. Some neurons are going to be on in your brain, most neurons are going to be off. Here we're using a very simple system with 5 logic gates connecting the circuit. So when you are seeing the blue dot, there are going to be blue neurons, presumably in area V4. Now by blue neurons, I mean neural correlate of blue in the usual sense. These are neurons that fire whenever somebody sees blue, that don't fire if you don't see blue. If you stimulate them, you're going to see a blue phosphine, and if you lesion them, you're not going to be able to see. Okay, that's the so-called best we have so far in terms of neural correlate of seeing blue, and this neuron is going to be on when you're looking at this display. So I'm saying one neuron, but it's just for the sake of the argument, as you can imagine. Now, in this particular case, we take a patient, there is a patient like that, is just not capable of seeing any colors because of brain lesion around the area V4. It's one case that's well reported. But of course, ideally, we would want a patient which would just kill the blue neurons, not all the color neurons, just the blue. So let's assume that guy is lacking just the blue neuron because we have inactivated it with optogenetics or whatever that might be, or a lesion. Now, if we could do the whole study of the conceptual structure presumably generated in the healthy subject's brain and the achromatopsic or abluopsic patient brain, we would find tons of concepts in the case of you seeing the blue dot, including the concept of blue, which is a first order concept in IIT, including the concept blue dot, which requires a dot concept, and then the two bound together say something more than just the two separately. That's how you get the binding of a blue dot, and many other concepts, okay, including negative concepts like not red and not yellow and not, so there are tons of negative concepts. So there are just a giant number of concepts, stars. We're just showing a few, blue and blue dot, okay. This is what happens in the normal guy. Now we go to this guy, we kill the blue neuron, and what happens is that this constellation of concept, the conceptual structure, we think is going to be largely unmodified. Basically, most of the concepts, positive, negative, higher order, etc., are going to be the same. Here, of course, we have a few, except for the ones supported, specified by the blue neuron. And here we have just two, but of course there will be many more. You have the concept blue is missing, because that neuron can't do that. But you also miss all the other higher order concepts that neuron specifies together with other neurons. Together with the dot neuron, it was specifying this higher order concept. Now that's gone too. Together with the sky neuron, it was specifying blue sky, and so on and so forth. So when you kill one neuron here, just one, you lose not just the concept of that neuron, which we call the blue neuron, but you lose all the higher order concepts that it contributes to specifying, which are really useful. We call this thing, the set of concept of stars that you lose when you kill one element in the complex, a Q-fold. Because this is a shape, a form in cause-effect space, you are literally losing a piece of the space, a fold or something like that, of the constellation, using a whole piece of the constellation. So it's not just that you have blue as one concept, it is a fold or something like that. Now this is by subtraction, we kill the blue neuron. Now let's do this by addition. So now we take a vegetative patient, and like some of those, so unconscious, gone, completely unresponsive, but some have a remaining piece of activity in their brain. And here we're sort of making the story a bit more beautiful than it is. We assume that V4 is working perfectly and the blue neuron is working perfectly, so whenever we show stuff to the guy, if we show blue stuff, this neuron is going to turn on because it has the proper afferents, etc., etc. So now it's the complementary picture, but see what happens here. Basically, in this case, this thing alone doesn't do anything. It's not within a complex. It doesn't specify anything. It would be here if it could, but doesn't even do that. So in essence, it's very different here, addition and subtraction. If you just start with the blue neuron, it doesn't do a thing. Nobody sees anything, there's no quality whatsoever. But if you take out the blue neuron from a guy who is conscious, who has this huge constellation when he's seeing this blue dot, you're going to see a gray dot. You're going to lose blue, but you're going to be conscious, and really you've just lost a Q4, which is not that much. Okay, so this will perhaps illustrate a bit what I wanted to say here, and you can sort of have a mental picture of this by thinking that if every experience is a form or a shape in cause-effect space, like this, then blue, or color, or vision, is just a Q-fold. It's basically a subshape in this giant shape, which is, this means to see a blue dot, ideally, projected into two-dimensional space. If we kill that neuron, we lose a full fold, but the shape is still there, so to speak. But if we have only the blue neuron, it's not that we have this part, okay, and that's seeing blue in isolation. You have nothing, okay? So this is very important because it tells you that a blue detector can do as well as your blue neuron, but it will generate no consciousness whatsoever. Your blue neuron doesn't do anything more than a blue detector, but if it is part of a complex, it will generate a Q-fold, okay? And that's what blueness means, okay? So to finish this part, and that would be a short part, now we go back to how David has actually usefully subdivided the combination problem and try to get a little bit more of an understanding of what IIT says about that. So David introduced the subject combination problem. How do micro-subjects combine to yield macro-subjects? And here the idea is in IIT there are no micro-subjects. There is no mini blue subject or anything like that. However, a set of elementary mechanisms, like ABC in our simple example, can yield a subject of experience if they form a complex. So no micro-subjects combining the little subjectivity into bigger subjectivity. There is nothing like that. There is a system in which elements can form and do that. Yes?
So quick thought experiment. So if we could somehow connect all our brains, would predict we'd lose our individualness and the winner would be some macro consciousness?
So right now we are connecting all our brains, hopefully, but it's not happening, as far as I can tell. The thing is, it depends how you do it.
Yeah.
So generally speaking, you can take any system, you can say, oh, well, let's connect them. Speaking is a form of connectedness. And of course that system is integrated in some sense, meaning you cannot split it without losing something. But then it all matters where the maximum is and at which spatial temporal grain is. And as you saw in these simple examples, it's a rather delicate thing. Okay? So the idea there would be that even if you connect this more and more and more, depending exactly how you do that, it's still going to be the individual subjects exist and not the whole. There could be a point in which that happens. And the best example that we sort of suspect from the literature is the split brain. The split brain tells you, okay, if you have all 200 million callosal fibers that connect your two hemispheres, you are one guy, one experience. If you cut it, you are two guys. There's plenty of evidence for this from the studies of Bizanik and so on. IIT predicts that if you were to slowly decrease the efficacy of the corpus callosum in a parametric manner, there would be a singular point in which you jump from being one entity to two entities for roughly the same amount of traffic across the callosal fibers. It's a counterintuitive prediction. So almost nothing at some point will change in the efficacy of the interaction, but suddenly you're going to go from being one to being two. So it depends very much how you do that. Yeah?
Just on the split brain, but then in that case, if one of the hemispheres did have a slightly higher phi, would it exclude the other hemisphere
Yeah.
at all?
Yes, well, it depends where the maximum is, okay? If the left hemisphere, say, had a higher phi than the entire thing,
Would collapse into the...
then you would have the left, and then the right presumably also would be conscious. If left plus right have a higher phi than the left, then the whole thing would exist. Okay, something like that.
Another quick question.
Sorry?
Can I ask another quick one? Or
Okay. Yeah, how are we doing with time? Yeah.
It's fine.
It's fine.
so, it sounds to me like in terms of the content of consciousness, I'm totally following all the axioms, and I think it really does a great job. But given the subjectivity of experience and consciousness itself, do you think we can apply it to exclude the existence of consciousness in general? But you know what I mean? If we say that it sounds to me a little bit like the richness of experience is related to the complexity of the whole system, which is true for the content of consciousness. But if do you think we can claim that there is no consciousness in a smaller subset due to the exclusion criteria? Not the content of consciousness, but the consciousness itself.
Yeah, well, I mean, exclusion says there is only one, and that's what my experience is like. I think we can perhaps move on a little bit and get back to that when I show some counterintuitive examples about why we can exclude consciousness, okay? So here I just want to just finish because I think it's crucial to deal with the combination problem. So this is sort of the IIT answer to the subject combination problem. The structural combination problem is how does micro-experiential structure deal with macro-experiential structure? So again, IIT says the macro experience is how the cause-effect repertoire of elementary mechanism, that is concepts, all complex, specify a conceptual structure. So there isn't really, if you go back to this, okay, it's not that you have that this is a little piece of experience and this is another little piece and you add them together in any way like that. It is, what matters is the shape, okay? What makes the experience what it is the entire constellation. And then as one concept, you specify that constellation in how you change the shape. In other words, you add an element that does something alone and in combination, it will change the shape this way. Okay? But there is nothing it is like to be that little thing in isolation. So again, this is sort of the way of looking at the structural combination problem. The quality combination problem is related. How do micro qualities combine to yield macro qualities like the redness of red? Okay? And you know, if you think of it in sort of the usual Panpsychism vein, again, sort of additive, you have these micro-phenomenological things, who knows how they feel like, then you put a lot of them together and somehow you get red or blue. IIT says, no, there is no such thing. What you do is a macro quality like the blueness of blue in that example is a Q-fold in the overall shape. The blueness of blue is this whole thing here. There is no blueness in isolation. I hope this sort of indicates a little bit how different this is. And then these additional problems that David quotes, I chose two here. The unit problem, of course, is translated very directly. How do microexperiences come together to yield a unified consciousness? Well, a conceptual structure, by definition, is irreducible. And the boundary problem, basically, how is it that my consciousness has boundaries? What it is, nothing more, and I add nothing less. Well, exclusion showed that to us. Exclusion says, indeed, it is bounded. That's how we start. And now, a maximum of phi tells you where the boundary is and at which spatial and temporal scale. So I will finish now with some of the corollaries of IIT. Again, no neurobiological evidence today, otherwise we can't get there. But just reminding ourselves that, again, if you take a physical system with mechanism and state, you analyze it, you're going to find a complex which generates a conceptual structure. This larger thing doesn't. There are minor complexes that generate small conceptual structures. We probably have plenty of those in our brain, I would bet. In addition to us, there are going to be some other consciousness within our brain. How big, I mean how high phi, and what they are like, I have no idea, but I suspect it's not going to be zero. And I think in some psychiatric conditions like dissociative disorders, it's quite intriguing that some of these may actually not be that small. Of course, in the split brain case, we know there are two consciousness within one brain, but that's rather easy because that's an anatomical disconnection. Structure matters a lot. A system like this, which is organized a bit like the cerebellum, in fact, with more connections like that, if you analyze it, it turns out to be not one entity, but three entities. Each of them is actually fairly trivial. It takes stuff, does stuff, sends stuff out, even interaction with the rest. But what exists is not one big system. There are many little systems, each of them with a trivial conceptual structure. So there is nothing that is like to be this thing, and there is very little that's like to be each of them. A system like this with complete connectivity, full connectivity, all on, every neuron is a majority, if fires it, the majority of input fires. If you analyze it, this is integrated, this is generating a conceptual structure, but it's very trivial one. It has 5 concepts, only elementary concepts, only what the individual units say, not couples, triplets, they don't do anything, apart from the individual units. and all the individual units say exactly the same thing. So it's the same concept repeated 5 times. It exists minimally, you barely see it. So this thing basically does not almost exist, and the way it exists is trivial. It has almost no quality. Same system with 3 connections instead of 5 parameters. So actually you decrease the number of connections. You make it specialized yet integrated. Suddenly you get 30 concepts, which is almost all the possible concepts, and you have a nice constellation. So it feels like something, 10.75, and specifically it feels like that to be that system. So it depends very much. It's not just a matter of being integrated, how it's connected. It follows that consciousness is greater. Here's a system with many elements connected within and across, etc. You can think of these as like brain areas with long-range connections. Some on, in this case, all on. This whole system exists, is a maximum, 10.56. Now we turn down the neuromodulators. We heard from Chiara at the ASSC that neuromodulators are key in determining whether you're awake, asleep, conscious or not. We turn them down, assuming essentially that reduces the efficacy of the interaction, the long-range interaction, which is sort of something that happens. Now this is still one entity, but its phi value is a third of before. So now this really is not easy to get in humans, because in humans it's really sort of a nonlinear collapse. Okay? But nevertheless, it tells you that consciousness can be graded. For instance, in minimally conscious patients, something like that is probably going to go. Finally, just turn it down a bit more, and suddenly the whole thing, while still somewhat integrated, is not a maximum anymore. It breaks down into many local maxima. So then there is nothing it is like to be this thing anymore. There is something, but not much, it is like to be each and every one of those 5 individual entities. Yeah?
Is there any sense in which what it's like to be those little sub-entities resembles what it's like to be the whole? Do they have anything in
Yes,
common?
at some level. So the overall structure, okay, of what those entities do, as long as they are big enough that they do say something about themselves, is going to be a bit like a subshape into the big shape. And that's very relevant when it comes to modalities, etc. But of course, we can only do it for very small systems, so we don't know these scales. This is just to say that counterintuitive prediction in active systems can be conscious. In IIT, you don't need to send any damn spikes anywhere. The whole system, if it is functional, it will say something, and it will be specifying an experience. Now, back to panpsychism. One thing that people have immediately caught onto is that IIT says that you can be conscious if you're just a photodiode. I mean, it has to be a photodiode with reciprocal connections as well as kind of photodiode. Yes, IIT says that phi from this thing is not 0. Okay? And you can check that this particular thing, if we go through the mechanism, we will understand it better, generates a conceptual structure. Plotted here is like these little 2 stars. That is what it is like to be a photodiode. It is like something, okay? 1. And it feels like this. Now, one thing I want to point out to you, because again, this is a bit counterintuitive, is while IIT says there is something that is like to be a photodiode with a memory like that, keep in mind that a photodiode that is on generates this conceptual structure. A photodiode that is off does exactly the same thing. A photodiode that is actually a blue detector, we use it as a blue detector, not as a light detector, from the intrinsic perspective does exactly the same thing. And finally, a thermistor that is not sensitive to light, but to temperature, from the intrinsic perspective, does exactly the same thing. So it feels like something, not much at all. It is qualitatively minimal, just this, and it is indistinguishable from the extrinsic perspective. This is a photodiode on, one off, a blue detector, a temperature detector. From the intrinsic perspective, it feels like just that, okay? Nothing more, and they're all the same. That's an intriguing perspective, what there might be out there. Another thing is, complicated system can be unconscious. And this obvious case is feed-forward system. Perfectly feed-forward system, you can make it as complicated as you wish, will not feel like anything because there is nothing it is like to be it. We can use it for anything from the outside, it will. From the inside, nothing. So it's not that IIT says everything is conscious, the world is suffused with a thin veneer of consciousness, as John Searle would say. No. It condenses down into little universes of consciousness, some trivial, some rather remarkable. One particular example is these 2 systems from the outside, from the extrinsic perspective, these black boxes with behavior, are functional equivalent up to 4 time steps in this case. Okay, so in line with what you were saying. So any question you ask, so to speak, of this system, you're going to get a certain answer. This was constructed in such a way that same questions, you get the same answer from this system. Now, this system is a purely fit-forward one. You can see it's less easy to build. You've got more neurons, more connections, but the behavior, the response to questions, the Turing test behavior, if you wish, is identical. IT says this is conscious, not much, but this one is, and this is not at all. So there's nothing is like to be that. From the outside, they're absolutely equivalent. You can't tell them apart from behavior. Then IT says all kinds of things about the brain, and that's where it has explanatory power. It can tell you why the cerebellum doesn't seem to contribute to our own consciousness, even if it has 5 times more neurons than the cortex. It can tell you, presumably, why the afferent pathways, why they determine what we see. The retina determines usually what we see in some sense. It doesn't contribute directly because you can cut it off and still see things, imagine things, dream of things. Why not the efferent pathways? Why not all those complicated loops inside our brain that obviously are essential for speaking, listening, understanding, and dealing with visual images? But if they are not part of the maximum, which we think they are not for various reasons, then they just contribute to what you do consciously, but all they do remains outside of consciousness. It tells you why, despite the fact that the brain is highly active, it becomes unconscious in deep slow wave sleep, while when you're super active and super synchronous during seizures, you lose consciousness. And again, in very simple models, you can basically show those kind of things. For instance, you can show the cerebellum I showed. Afferent pathways do affect this, but they don't matter. Loops, this is an interesting system that has inputs and outputs to this, but the maximum is here, not there. So even if you're connected, there's going to be a maximum somewhere in your brain, that's you, and everything else outside of the maximum is stuff that affects you, but it's not you, and it's presumably not even conscious. Crucially, it's important then to look at brain islands, newborns, and now I love to say plants, robots, bees, and so on, octopi, or sleep-waking patients, or even computers. Those cases in which, if you don't have a theory, we can go on forever talking about whether the behavior is intelligent or not. I believe that a bee being able to do all the remarkable things it does certainly gives us reason to ponder. Okay? Well, we see this in humans. We tend to attribute consciousness to humans, and generally speaking, we are right. We see this in a bee. It's more difficult to say, but it should at least lead us to ponder. However, now we have computers that do remarkable things too. And there, they have not been developed in natural selection, but it becomes a difficult question because behavior is not enough, intelligence is not enough, complexity is not enough. We need to go back to what we know for sure, our own consciousness, and derive the postulates from the axioms. So again, we can say things about simple system can be minimally conscious, when they're photodiode, inactive, can complicated system can be unconscious. In fact, functional equivalent systems can be true zombies. They have nothing it is like to be them. And I want to finish just by saying, because I think this is a good place for discussion, that I believe the biggest problem is going to come, not so much even from patients right now, but from the machines we are building, who are going to be better and better, already very good, like IBM Watson, the self-driving cars, and then the next generation of Siri, in passing all the intelligence tests you want to come up with, and they can put in emotion and learning and you name it. There is no fundamental problem there. But we do have the problem, again, to ask, is there something that's like to be them? Or even worse, we can simulate, or it is being claimed that it will be soon doable to simulate the behavior of each and every one of the neurons in our brain. This is the Blue Brain Project, the Human Brain Project in Europe. Assuming that could happen, its behavior would be virtually indistinguishable from ours. In fact, it would be like mine if I had downloaded my connectivity into such a Blue Brain Project. It would also have the internal states that are virtually identical to mine, so it would fit with the functionalist interpretation, not just the behavioral interpretation. And yet, IT says there would be nothing it is like to be that, and I would be more than happy to turn it off when needed. Thank you.
Just on the combination problem, so I guess it's now fairly clear to me that you avoid the combination problem for panpsychism by avoiding panpsychism in the strictest relevant sense. That is, you avoid having to get macro experience from micro experience at the most fundamental level, because you deny that there is micro experience at the most fundamental level. I mean, I guess for at least two reasons. One is I presume that quarks, on your view, will never in fact be conscious even in isolation, because you need two units together to get a conscious system, and these are only single units. Furthermore, even if they were sometimes conscious, or two-unit systems can be conscious, in the context of a conscious brain, exclusion would kick in, so you wouldn't get consciousness at that level. So basically, on your view, the macro experience of a human isn't constituted by putting together a bunch of micro experiences, so you avoid the problem. But at cost, I think, when the worry then is that now that the picture is no longer about precisely panpsychism in that sense, it looks like it's potentially at cost of a certain kind of emergence. That is, we're getting this macro experience, but you're only getting this macro. I presume that these quarks, on your view, do have some kind of autonomous reality, and they exist as some non-experiential reality, and it so happens when you hook up enough of these quarks in a particular complex way, then somehow you get experiential reality. And now this looks like that's kind of brute holistic emergence that raises potentially some of the problems even of traditional dualism. I mean, there's a causal problem and many others. I know you've got a line to take on causation, but one might think, for example, that ultimately whatever work the macroscopic states of the system are doing somehow ultimately derives from work that the macroscopic states are doing. Anyway, so.
Yeah, so there are really two questions that you asked. Okay, one question is avoiding panpsychism. Not that IIT was trying to avoid panpsychism, it's just what it is, okay? You may end up having the emergence problem, okay, brute emergence, something out of nothing, so to speak, while you get rid of the combination problem. Now, I told you, I think it's not getting rid of the combination problem, it's we actually addressing the combination problem. We say, how does experience come out of this mechanism? So two things to be said.
The combination problem is much easier when you don't have to get macro experience and micro.
Yeah, but I mean, this is an accurate, precise way of saying how do you build an experience. Now, one key thing to say, not with a slide really, but is remind you and remind everybody that the identity in IIT is not between an experience and a set of mechanisms in a state. It is between an experience and the conceptual structure. So the way we normally think about that, and certainly in panpsychism, is that you have these micro-physical elements that have an associated micro-phenomenology, and then somehow you have to put them together and you get the macro-phenomenology. Instead, IIT says, because it starts from experience itself, etc., let's postulate there are mechanisms in a state, but then the identity is not between the experience and the mechanisms, it's between the experience and the causal structure, cause-effect structure that this would specify. So this is important because that's the level at which even the combination problem gets addressed. You can study how an element contributes alone or in combination to experience, but it does it within a conceptual structure, not just by adding on to another element. That's one thing. The second thing is that because we start from phenomenology and we postulate there is a physical world, again, it's a good postulate. I personally, I don't think anybody really know what the physical world is really made of. So for instance, it could very well be the case that it is quarks or it is fields. I mean, that's basically the issue right now, whether it's one or the other. And whether it's discrete or continuous, and many people begin to think it might be discrete. But whatever it is, for all I know, it might be made of dyads. That is, the actual physical world turn out to be made by a mechanism that needs sort of two parts, at least. Otherwise, they would not even exist. Now, this is something for science slowly to decide. Right now, it's undefined. And IIT is sort of non-committal about that. But one interpretation would be if it turns out that even the most elementary things, or fields, require an interaction between two, so then there would be room for them being indeed something sort of universally available in terms of consciousness. So that's intriguing. I mean, I don't know.
And if it turns out that the fundamental elements in physics are atoms?
Well, if it turns out, then they would not be conscious.
And then it starts to look like all the fundamental causal work is done by these
by the things that, yeah. So yes, but since it's a postulate about this, I would rather postulate that they are dyads, but I won't go into that. However, your second question that comes up here too is why I have sort of this slide to illustrate that. So you say, well, because of exclusion, the macro conceptual structure excludes any conceptual structure inside that. That is true, but that is only true where there is causal overlap. So if you have the macro groups here against their constitutive micro elements, then when you do the perturbation and calculate phi, etc., it's going to be that either the macro level wins, like in this case, or the micro level wins. But when you perturb the macro level because of supervenience, you're actually specifically perturbing all the micro elements. You just perturb them in particular, likelihood of being in some different states. So then
you should emphasize that the blue errors don't actually exist. I mean, the blue errors are just the macro interactions.
Yeah. So there is supervenience, meaning this is really, if a physicist would describe this is what's happening, this is how we perturb it. We just take it as self-defining at the macro level to get some. Then there is competition in terms of causal exclusion. Either these things are doing causal work or these things are doing causal work, but not both. And we just see who wins. However, if within, say, if this is a neuron, within a neuron there are two mitochondria, just to be concrete. And within the mitochondria there are interactions between the parts of the mitochondria and so on and so forth.
Moving the particles in the air. As a result of my speech and so on. It turns out that my consciousness never actually affects any particles, and this would be at least a counterintuitive.
Well, yes and no. So for instance, if now you forget about the mitochondria, which is at a different level, so we have no problem. I'm not having conscience doing anything to the mitochondria as such. Okay? But now let's say that this is responsible for a voluntary action. Okay? If it turns out that phi is maximal at a certain macro level from the intrinsic perspective and not at a certain micro level, then it is correct in cause-effect term, so the terms that really matter, to say that it was the macro level, that is consciousness, that did the job, as opposed to my neurons did. So this exclusion here applies, but not the way that, say, Kim would say it. Kim assumes that the neurons, because they are more detailed, have all the causal power, and there is no further causal power than that by causal exclusion. But what we showed you with this macro-micro demonstration, if you actually go and measure causal power properly, you may find situations, I think in biology some of the rule rather than the exceptions, in which the macro level has more cause-effect power than the micro level. And then, by exclusion, it's correct.
Right. I understand you have this very nice measure where macro causation can outstrip micro causation, but it still looks like in any given specific case, what goes on in the macro causation will somehow derive from, be derivable from everything which is going on at the micro level, right? We can look at those non-experiential causes, everything they're doing, and add them up and do the supervenience thing and say, okay, everything that happens at the macro level can be derived from, and indeed it's explainable in terms of all those fundamental non-experiential elements. Which is not to say that you can't give some cool macroscopic measure of it, where it turns out...
No, it's not a macroscopic measure. So supervenience means there is no magic extra ingredient here, okay? This is granted. But it also means that if you ask who was responsible for the action, the correct way is to measure who had more causal power. And if the one that has more causal power turns out now to be at macro level, then that was it. Okay?
So can I give an example of that? In grammar learning, you might have a noun and a verb, and every instance of the noun is very, very low frequency. Mm-hmm. At the micro level, you might have problems, but at the macro level of noun predicts verb for your sentence structure, the macro level would have more coherent structure.
Yeah, I totally understand that the probability measures which come out higher probabilities given a certain macro state than the micro state. It's still the case, even in this case, all the macro level causation can be derived directly. If you knew every last micro clause, micro element in its micro causal structure, you could just derive the macro causal.
So no, if you go back to this for a second, just to clarify, then we take that question. So this is the micro level description of this very simple system. This is it, okay? And there is in this case some degree of noise, etc. This is what actually you do at the micro level. We don't add any ingredient at the macro level. And this is, and I'm now talking description, the macro level description of that system, okay? If I want to know what is actually going on here, okay, this description tells me more than that. Although it is supervenient upon that, that is, I'm not adding anything to it. So then it really, but it was assumed, I mean, essentially Kim and others, always assumed, given that this is more detailed, it has all the causal power. But now, if you define causal power, hey, I must say, this is where the action happens, not this.
It's relevant to this, actually relevant to most things. It's what strikes me is that when you say something like measure the cause effect, the causal power properly, measure the cause effect repertoire properly, and thinking of consciousness as associating with properties of these cause-effect repertoires, which is why it's not thinly smeared all over the universe. I'm thinking now about panpsychism. This seems instead to imply a slightly different kind of pan-something or other, which is a pan-informationalism. Because what you're suggesting, because all these cause-effect repertoires are defined, as far as I understand it, and in IIT are defined in terms of counterfactuals. What would happen to a system for all possible perturbations, for all possible states that it could be in, for all possible input-output combinations. These input-output combinations need not have actually taken place, which is, for example, why an inactive system, very counterintuitively, can nonetheless be conscious. But this then means that for all these concepts to work, as far as I can see, to work through, you're saying that actually there's something like information is real, in a Wheeler type sense, to be a little bit imprecise about it. But I'm wondering whether there is a sense in which that, for the story to play through the way it does, we now have to assume that information is real, and that it's then properties of aggregations of information that determine whether we have consciousness in a particular part of the universe or not.
So, it's, at some level, this is an excellent thing to discuss. I just want to make sure that we know which information we're talking about. I'm just looking for a slide. If I don't find it, too bad, okay.
I mean, and I'm aware that we're not talking about Shannon.
Yeah.
Shannon information as a method is different from saying that.
So there are all sorts of differences between Shannon information. So when we talk about information, inevitably confusion arises because there is the usual notion that we all have, and there is Shannon information. This is a very different one, as I try to show. It is how a cause, how a physical system informs. In that sense, it's good to call it information, the space of possibilities around it, essentially in the past and the future. And you only do it if you're integrated, and you do it only one way, you do that specific way. That's essentially what IIT says. And that's very different from Shannon. Okay, so then if you say, okay, let's call this thing information. This is the information in the sense of how you specify the space of possibilities around you. Okay? And you say, well, then that means that information is real, and if you wish, there's this condensation or maximum of information, or integrated information, the right way of putting it, in the universe, presumably of which we are rather big maxima as far as we know. Well, yes, that is correct. I think that's what it would say. But now I think there was implied a little bit in your question that of saying, well, is information being real? Is it really real? Remember, it starts from consciousness. Consciousness is real. Okay, that's the only thing. We are sure it's real. So if this is consciousness, if a conceptual structure, an integrated information structure, is an experience, then of course it is real.
So you put it that way around, that the sort of ontological state of information follows from your axioms about consciousness.
Yes, it follows, because the ontological state of consciousness is undeniable. I think you would agree with that, no? Yes, that's the one that is undeniable. Yes.
Can I ask one very other short question, and then I'll stop, because there's many things I'd like to ask. But I mean, again, starting from axioms, you go very, very far with these axioms, which is beautiful to see how far it goes. But if you start from the other way, which, as you say, would not work because you can never squeeze consciousness out of the brain, but you can at least be falsifiable more easily. If I make a claim that consciousness is associated with area X or synchrony Y or causal density Z, then I can sort of test it and rule it out. Starting the other way around, and we have now 5 axioms. There were fewer in previous versions of IIT. Maybe I could add other ones like it needs to be reportable. A lot of people, I don't believe that, a lot of people might believe that. But what would be the single simplest way to refute IIT, since you start from axioms and go down?
Okay, so again, 2 things here. It's not a short question that you asked. Okay, so the axioms and the axioms of integrated information are 5. They don't need to be 5. Okay. They always were sort of 5, except they were not presented explicitly for various historical reasons. But existence was obvious and so on and so forth. Okay? But it is true, and we discussed this with David yesterday, that nobody can be sure, certainly not me, that those are all the axioms you need, or for that matter, it could even be that there are some extra axioms that we don't need. Okay? That I very much doubt. Let me just show you this one. this is sort of the logic behind the axioms, okay? So, as in general with axioms, right, they should be about experience. They shouldn't be about report, prefrontal cortex, you name it. They should be about experience itself. Otherwise, we are immediately moving to the issue about the physical world, okay? That's where we're starting from. They should be evident, which they sort of are, but one can always argue. And they should be essential. That is, they should apply to every experience we have with no exception. That's how these 5 axioms have been identified. And as typical axiomatic systems, you would want them to be complete, meaning you don't want to be missing an axiom. You want them to be consistent. They should not lead to contradictions. And you want to be independent. That is, you cannot derive one from the others, because if you can, then you can throw one axiom out. Okay, that's typical of axiomatic systems. Except these are very special axioms because they are axioms of experience. Okay? So rather than the axiom of geometry, of set theory, etc., these are really the axioms we are sure about in some sense. Now, I'll just throw it in again. There are some possibilities. Typically, one for me is time. Should one add the axiom, every experience is such that it flows in time? It's sort of natural, and many people think that, etc., etc. And I still think that probably you can do without it because you can derive it basically from causation, cause-effect information. So this is an open issue. I'm not saying that these are the axiom and that's it. I think it's a pretty good starting point, and I think you can go very far with this. But some things like time, for instance, one can have issues and one can wonder whether one would add it or not. My basic strategy here is to say I do it as little as I can, and I only add an axiom if there is something that really cannot be explained. However, they cannot be axioms like it must be reportable, or it must involve the brain, or something like that, because then it's really a jump. We suddenly go into something which has nothing to do with our own experience. The beauty of this is about experience itself. If you're saying something about the world.
There are people who would say that it's actually that experiences are always reportable.
Yeah, but that's not about experience. In fact, all the controversies happen in people who say there is experience that cannot be reported, then you go into all the usual stuff. So you have to remember here the starting point. Maybe it's the wrong starting point, but it is about experience itself. Forgetting about brains, forgetting about anything. Now, this doesn't mean that it is not falsifiable, because I mean, as Marcello showed the other day, first of all, there is a lot of data we already have about the brain that find a parsimonious explanation with these 5 axioms and postulates, at least in principle. In practice, it's difficult to measure, but... And then we went, and looked for the technique that would allow us to, very roughly, see whether, as a first pass, if consciousness goes away, well, some version of integrated information should also go away. And if it comes back, it should come back. And that's what we, over the years, tested, and so far, so good. Meaning, in many different conditions, in individual subject, etc. It's rough, it's very approximate, but it sort of works. And other tests, like, the callosum or the inactive cortex, etc., there are various tests, counterintuitive ones, that can clearly falsify the theory. And one day, we're not there yet, you should be able to ablate or stimulate or add neurons to the subset of neurons that's generating your consciousness now, and evaluate whether the way the conceptual structure that the system generates is changing the way your experience changes. So it's definitely falsifiable and accounts for a lot of data we already have. But if you tell me, does a plant have consciousness and what kind, right now we can't even begin to do that. More importantly, it's again crucial to say, in IIT certainly you don't go from the plant. So we never would take a plant or a sophisticated behavior bee, or a computer that answers a question better than you do, and so on and so forth, or something that looks very complex, or for that matter, an expander graph, or so, and say, well, that's very complicated, it must be conscious, or that is too simple, it can't be conscious. This is not the way to go in IIT. You start from your own experience, and you extrapolate from there. This is a key rule, because the only place where we know it is there is ours, and that's the only place where we can validate properly.
So, continuing directly from that, if the idea is that in the long run, by itself, if we can calculate for real living systems, should enable us to estimate literally the amount of consciousness present in the system, wouldn't there be a calibration problem? From the point of view that we only have a single meaningful non-zero point? Unless we assume that the relationship is entirely linear.
No, we would not be assuming anything. Practically speaking, right now, what we have, sort of comes back again, is let's say we could sort of measure phi or something close to phi in you now. Then we anesthetize you with propofol. And that, we know how it goes. Within 2-3 seconds, you're gone. Meaning, if I wake you up, you tell me I wasn't there. Okay. And sleep is a bit more gradual, but still, it tends to jump down when you lose consciousness. So, in many ways, it's sort of non-linear the way it happens in humans when the manipulations you can typically do like anesthetics. But, conceivably, you could actually try to titrate it down. Minimally conscious patients is one case, but better, I think, sleep is actually, now that we can study it better, if you heard Francesca, okay, you actually may have situation in which half of your brain, like sleepwalking, is in an inactive state and half is sort of still okay. And then if we could measure phi there, we might get an intermediate value and so on and so forth. So I think, in principle, one could progressively fill in the points, and it doesn't have to be non-linear. In our brain, it probably will be, just because when it's not capable of communicating well, it at some point will just collapse. But doesn't mean that phi is non-linear.
Okay, so that's all within the same species or the same neural system where we titrate within the state of the system. But I was referring to the claim that we could use phi to estimate how conscious any species is, for example.
Yes.
And is there an assumption there that the amount of consciousness is linearly dependent or linearly defined by the value of phi?
It's a perfectly fair question. I think it's a matter, again, of best inference. So, in other words, let's say that this thing goes on and we get more and more validation for the notion that our own consciousness, its level is related to phi, its quality is related to a conceptual structure, and we add and add and add. So it's the best we have right now to evaluate human consciousness. Now we go to an animal or to a plant. Let's say we do these things and we get a value and a shape. Okay? Are we justified in inferring that, because we would be non-conscious at that level, then that animal is basically minimally conscious, and that its experience would be sort of like that? We are not in an absolute sense, because it could be that it's radically different thing in animals and different species, but, Occam's razors and parsimony and the inference of the best explanation would say this is the best we can do. The opposite hypothesis, that is radically different in every species, is much less parsimonious than the simple hypothesis. Okay? That's all I can say.
I'll ask you about it, but there's a follow-up, but it's 5 times later.
This is relevant to what I've been working on, but also it's a version of the question that Olivia asked before. So say we have a system of a brain, a human brain, so you know it's conscious. You know it generates a big phi. Say you know that. But you can only measure a part of it. So does the partial measurement say then you measure phi for the partial system? Does that have any meaning? Because you don't know what the maximum, you haven't been able to measure the maximum. Right? So what can you say about just having a partial measurement of this system? It is giving you a phi. Should it resemble what if you did a larger measurement and get around the entire system? You can expect it to resemble
especially if that part is definitely included in the complex.
Yeah, say you even know that. Say you even know that part is included in the main complex.
Yeah, so the answer is I don't know. And we don't know right now because we are not able to really even scale these things up to very bigger systems. So one way to get a feeling for that would be you can make, indeed, just as you say, a bigger and bigger system. You keep one particular set of mechanisms the same, and you see their contribution to the conceptual structure of a small system, a progressively bigger system. And can you infer something about the bigger system from the small ones in models? Practically speaking, we have not been able to do that because we can only do small systems, so we cannot scale it. We don't know how it scales. It's a similar question, rightly, to the one about using TMSEG or something like that to evaluate phi. Clearly, you're at the wrong spatial scale. You're at sort of temporal scale is probably okay. All you get is a differential. So far, it seems to work well. I think there are good reasons to imagine why there could be a scaling, and one could make a mathematical argument. But honestly, right now, more than that, I wouldn't feel like I can say.
A bit related to question to Anil's one. I really don't like this argument, but some people say like Metzinger self is really important, right? And most of the argument I'm not really buying, but the one particular thing I found interesting is that, let's say, Francesca's, experiment, we wake up the, person in non-REM sleep, and then you wake up, and then they can report the dream, right? But presumably, under the non-REM sleep, complex shrinks, and the level of consciousness is very low, and shape of experience is very different. And then when you wake up, you can kind of retrieve that, experience at that, very small, complex. If you are being, sort of identified as one particular complex, the complex itself is different at that moment to that moment. How this, guy knows about something completely alien, which is really weird. And same thing can be actually addressed for even more weird case, like your thought experiment, or maybe empirical experimental proposal for cooling down corpus callosum, right? Let's say we split into two at one point by cooling the corpus callosum, and then those two have completely independent experience, and then you warm it up. Do we have access to two previously split experience as one thing, or I don't know, how do you?
So let's just use this because there are more data on this, okay? But then there's something we say about sleep too. So two things are known. One is what is the difference in report between patients before the split brain operation or normals and after the split brain operation. And it's clear, for instance, the easiest thing you can demonstrate is that things shown to the other visual field and only to the other visual field are simply not experienced, period. Okay? So that's a fact, and you can show where it is like that and a few areas where it is not like that. So clearly there is a big difference in experience. The guy simply doesn't know about what happened. The other guy does after the split. The other interesting thing is that after the section, by and large, the guy, the left guy who talks, he's not telling you, I've lost half of myself. He is systematically sort of going on a bit like before, okay? Well, he can do roughly the same things, he can talk roughly in the same way, but he doesn't sort of feel the loss of something. This is very true. We heard a presentation about that in neglect also. In neglect, you lose some part of the brain, and suddenly some half, the left half of the visual field, is not there, but you don't feel like it is missing. And much of neuropsychology tells us cases of the sort. So interestingly then, in dreams, like in Francesca's study, it's good when we wake up people and probably the brain is like lesioned in different ways temporarily, some parts are off and some parts are on. And you can really sample a rich phenomenology. So if you take an extreme view of what she found with the awakening, which was pure thought, and the activity was primarily here, and pure perceptual experience was primarily there. Okay, not just both, but like that. Are you the same experiencing creature when you are being a creature of pure thought, and when you are being a creature of pure experience? Well, it's certainly from the same brain. In my mind, you're not the same creature, you're a different experience, okay? Usually these two tend to go together. And the same is true for the autobiographical self, for instance. When you wake up in the morning, sometimes you're not there as a self. You have the experience, but you don't know who you are, where you are, why you are there, and what's your history. And I'd like to say you don't even know whether you're male or female, okay? So you don't know any of this. Then he comes back to you, and suddenly you reintegrate this part and you become a fuller self. But it's not that you weren't there before, okay? And that you is, of course, not the same you as when you have your autobiography with you, but it's an experiencing subject, or whatever you want to call it. So I think we have to have, a rather flexible view what it is like to be somebody, because we have, it's natural, the tendency to think that we are us, but there's a whole thing in philosophy and even in different cultural traditions where we know that us, is a bit of a misnomer sometimes. There's a continuity in time, etc., but the me who is thinking, brooding on something when I am having a pure thought dream is not very much the same me that's talking to you now. So,
do your 5 axioms say anything about how to individuate one single experience? Is it different from individuating the subject experiences, or just not?
it's the same thing. So in this, there is not a subject-object distinction. something exists if and only if it makes a difference to itself. And that's all it takes to be a subject of experience. Okay? And the content of the experience is that shape. So we could go into this forever about subject-object distinction in philosophy and it's relevant for consciousness, but this definitely says if you are a form in cause-effect space and you are maximally reducible, that's all there is.
Can you have moments of high tide that belong to different time scales?
So
that coexist at the same time?
No, so the exclusion axiom says no, at any given time, so to speak, you exist at that time scale. And that's probably going to be around 100 milliseconds or so, as we know from lots of experiments. And actually, if you think about how the neurons are, it makes sense. It sort of follows that that's a good time scale because that's where the system can generate the most integrated information, just biophysically, okay? That time scale may actually shrink and expand a bit. So we know this anecdotally, we know this experimentally, that you can actually prolong the sort of instant of experience by doing some manipulation. That goes from psychedelic drugs, that typically do that, to intense emotional experience like an accident or something like that. But also, it's sort of a testable thing because you literally could change the EPSP duration and therefore change the timescale at which the interactions within a system are maximal to predictably change the duration of experience, okay, according to this. But again, IIT would never say that you can exist at multiple timescales simultaneously. We didn't show the example, but that's definitely what IIT would predict. So the timescale can change a bit, but you cannot exist at multiple timescales simultaneously.
Just a couple of things. It would still be possible for something long in the past to have some, to form your immediate experience,
yeah.
Just as you said. The other thing I'm kind of struggling with is what space, phase space or what you like, do we consider this? Because it's, we talk about elements that are 0 or 1, but for example, I could have two parts in two-dimensional space plus time, or something like that. And if they're connected, even I think in a pretty simple way, they would exclude all of the other places in space that could have been before, plus or many other places in space that could have been in the past. But it seems to us to be kind of, we look at spiking or something like that. But it's not immediately obvious that that's actually the limitation of the system.
So this is, if I find the slide, otherwise forget it. It's, okay, forget it. I'll just tell it in a few words. This is one of the important issues in neuroscience. Let me make it concrete with respect to neuroscience and see a little bit how IIT can shed some light on it. There are issues where the unit of function of the cortex, and certainly the one that matters for consciousness, is it a neuron or a group of neurons? That's in space. There is the issue of the time scale, we just talked about it, it's sort of reasonable, that's a bit. And then there is the issue that you're referring to in a way, which is what are the states that matter? For instance, here we have binary units, so there are only two states, that's easy, okay? But if you take, even if you assume that the neuron is the spatial unit, okay? Well, does bursting matter? Does high mean firing rate matter? Does low zero mean firing rate matter? How do we distinguish 50 different states, 3 different states? Do we cross-grain or not? Does a burst make a further difference compared to a mean firing rate? Those interspike intervals matter. All the issues that are under the rubric of neural coding, okay? What's the code the brain uses? IIT gives a very precise answer to that, although not the empirical answer yet. It is a maximum of cause-effect power. So even for states, when the system self-defines, it self-defines in terms of the spatial grain, as we showed, the group or the element. It self-defines in terms of what is the interval where it makes most of the difference to itself, and it's not necessarily the micro-interval, but it also self-defines in terms of what are the alphabet of states that the system could have. So for instance, it may turn out that in the cortex, by and large, it's bursting, high mean firing rate, and low mean firing rate. That's all there is. And in further resolution, interspike intervals, etc., while from the outside, you can show that it makes some little difference here and there, and you can write lots of papers about it. But for the system itself, there is going to be a maximum, and that maximum may be those 3 states. So it's very interesting because it says you can come up with all the codes you want from the extrinsic perspective. You can describe the system at many different levels, but in terms of cause-effect power, there's a level in which it makes most of the difference. That's the level in which it exists. Okay, something like that.
So you get an awful lot from your 5 self-evident axioms of experience. somehow from these five axioms, this massive, complicated theory. I guess it's a kind of Kantian transcendental deduction of these conditions for the possibility of experience.
That doesn't sound like a compliment, but
it's not transcendental deduction. You get so far with it, this theory, it gets a little bit complex and maybe even baroque in places. If I might start to wonder about to what extent the steps are actually deductions, and to what extent they go beyond the axioms. And this is going to apply, especially I think at the level of translation of the axioms into postulates, and then the way you cash out the postulates. So I guess one could raise a worry in any individual case. But one case I'm particularly interested in is I guess the key axiom of integration, which is really playing a very big role for you in the theory. I mean, the phenomenological axiom there is something like, well, yeah, there is a single state of consciousness, which is a unified state, which is somehow, and you were saying, somehow distinct from the sum of its parts. I think a lot of philosophers think about the unity of consciousness. So yes, I mean, the datum is that there is in fact a single state of consciousness, for example, made up of all the different modalities and so on. They don't necessarily, I think, deny that it's the sum of its parts. You might be made up from the visual consciousness and the auditory consciousness and the olfactory consciousness. The important thing is there is a total experience. It's not just 5 separate experiences. There's a total experience. Quite a lot of people, though, are quite happy to regard that total experience as a sort of mereological sum of putting the parts together, as long as it's still a total experience. So this, I think now, if that's the datum, this thing interacts with the way you want to cash it out in terms of cause-effect structures. You somehow want it's very important to you that the total experience have this new causal power, very, very much over and above the causal power of the parts. So to what extent you can get that as a datum out of the phenomenology. If I think about a case where maybe my whole experience consists of auditory consciousness and olfactory consciousness. I'm hearing some music and I'm smelling something. These might have, let's say I do in fact have a total experience of hearing and
let's use an example that I like. It's called a flashback. So it's visual and auditory.
Well, the hearing is smelling, so it's not simple. Yes, vision and hearing bring in all kinds of complicated good spells.
So flash smell.
Spatial and so on. So let's do hearing.
Flash
smell. And hearing some music and smelling some grass or something. And then causally, in terms of their causes, they might be totally separate and autonomous. In terms of their effects, you might think they're very largely distinct. Now there is, of course, the possibility of some kind of interaction in their effects. I can bring together the fact that I'm hearing this music with this kind of the fact that I'm smelling this grass, and I can say things like, oh yeah, I'm hearing this music when I'm smelling the grass, and so on. There's not really a terribly rich interaction between them. So at least it's tempting to think that in a case like this, in fact, the cause-effect structure of the whole is to some fairly large extent divisible into the cause-effect structure of the parts, the hearing and the smelling. And it doesn't need to be this massive new integration going on, but most of the cause-effect structure of the whole being somehow autonomous. So at the very least, the claim though it seems to go well beyond the phenomenology. You can say more about.
Yes, I'm afraid it's promised that it's a lot more, but try to stick to the fundamental thing. So we used to talk about this in terms of the flashback, but it would be in your case the smell bank or something like that. So an experience where you have two modalities that are sort of rather orthogonal, and yes, you have them together. I mean, you sort of admitted that. Some people would even deny that. But it's true. There is a total state, as you call it, in which you have both. I'm just paraphrasing. You tell me if I'm right or wrong. But they seem to be within themselves largely separate, also in terms of cause-effect structure, correct? And so this total thing may be more than the parts, but maybe not that much more. So, is that justified? So you have to remember that when we look at the cause-effect structure, so if we were to take that system, of course, I'm not going to say this is vision and this is smell or hearing and so on, but you take a system, when you do the cut for the integration, so let me go to the integration here. When we do the cut, we cut the system between, say, the auditory areas and the smell areas, and then we see what happens to the structure. Here a lot happens, okay? In general, the claim here is a lot will happen, because you're not just cutting essentially the few direct interactions there are between the smell and hearing parts, so to speak, which, because there are modalities we're rather talking about, are not many. But it is all the higher order concepts that are called A, B, etc., which there are tons, that are contributing to the big phi. So it's not just one cut of the direct interaction between those two, it is all the higher order concepts, this combination of elements that form the expression what it is. So generally speaking, that's going to be very high. If it is not very high, then you would literally indeed split into separate modalities. Then there would be one visual consciousness and one auditory consciousness. That would be the prediction. So the thing here is there are going to be a lot of high order concepts, that's why you get a very high one. Now, this may be right or wrong, but that's what we expect. And one thing to say about that is that in the previous version, so to speak, of IoT, so version 2.0, because we couldn't really calculate everything, we were just doing a split at the top. Okay, so we were asking, is the system irreducible if you cut it? It would be basically just looking at this level here, okay? And then you get a value that in that case may not be very high. But what is done properly with 3.0, with a full extensive characterization of this, we do a cut and we check all the concepts, and then the claim would be used a lot. Now the more interesting part, and I'll finish there, is IIT in one of the papers predicts, roughly speaking, that modalities will turn out to be clusters of concepts in cause-effect space. So if we could really work this thing out, we would see that there are a bunch of hearing concepts that tend to be closer to each other in cause-effect space, clustered, and then a bunch of smell concepts that are going to be close to each other, clustered. And so they're going to be like that. But then there are going to be a ton of higher order concepts that sort of bridge them. That's the claim. If this turns out to be radically wrong, so then I think IIT is wrong or something.
The question wasn't exactly though about what the theory says. I understand the theory says sophisticated things about this. The question was how you get those claims of the theory, whether those claims of the theory really can be read off the phenomenology or whether they're somehow going well beyond the phenomenology. I just don't see how you get, it doesn't obvious to me how you get from the phenomenological fact of unity of consciousness that there is a hearing and a smelling experience, these very strong claims about causal interaction.
No, wait. Otherwise, I don't understand what you are saying. So you granted that having this hearing and smelling experience, the total experience, cannot be